Our next speaker is absolutely brilliant. Yet again, another dear friend of ChainSafe's. There's a talk on IPFS and libp2p in 2020 from Protocol Labs, Molly Mackinlay. Molly, how you doing?
Doing well. Can you guys hear me?
I sure can.
Awesome. Cool. Thank you guys so much for having us. This is really amazing. I'm really enjoying the talk so far.
Awesome. Well, the floor is yours.
Well, excited to chat with you all today. Wanted to give a fast lightning tour of all of the really exciting stuff that's happened with IPFS and libp2p in the past year. I think probably a lot of folks last engaged more heavily with IPFS, maybe around the April-May timeframe when we had our big IPFS 0.5 launch. So I'll recap that briefly and then also dive into some of the cool stuff that's happened in Q4. So for those of you who aren't super familiar with IPFS, it stands for the Interplanetary File System, and it aims to take kind of the centralized HTTP web where many different end users must all connect to the same server in order to get the data to a more distributed peer-to-peer system where you can have subnets operating that are partially offline. You can have a much more flexible system of nodes directly accessing content on each other. The way it does that is by, instead of addressing location data by where it's located in the network using location, it instead uses content addressing in a global namespace to be able to move data around a network and uniformly verify that the data you're fetching from any random node in the network is the data you're looking for. And this aims to address a whole ton of different problems. It's been used a good bit in kind of either offline first use cases or in efficiency use cases or in places where you really need to verify that the data that you're timestamping into a blockchain, for example, is the data that you mean to. And there's a whole ton of security benefits that come with that as well. It also helps a lot in the resiliency robustness case of kind of links breaking because something got moved from server A to server B. When you're content addressing data, that same content will always have the same name. And that helps a lot in a ton of important use cases. And so there's lots of fun problems to solve here. IPFS is part of kind of this, what I've been colloquially calling the interplanetary stack, but this set of protocols that build on top of each other in order to make kind of a distributed peer-to-peer web possible. And so IPFS builds really heavily on top of libp2p. I'll also talk about a few folks who are using just libp2p, say, to power various blockchains that are have been launching over the past couple of months. It also uses IPLD, which is the data layer for how we actually form files and DAGs, distributed acyclic graphs of data that we can then move around the network. And then Falcon also builds on top of this whole stack and adds an incentive layer for fetching and finding content in the network. As I mentioned briefly, libp2p is kind of this modular transport layer. And so it's actually made up of a whole ton of different sub protocols, which then fit into kind of finding and exchanging data with nodes within the network and setting up those sorts of connections. And is used super heavily. And a lot of the improvements that we made to IPFS over the past year actually involve kind of the deep changes and improvements within libp2p that then flowed into benefits up the stack in IPFS. There are a whole ton of people who are building on top of IPFS now. We actually have an open Figma diagram where anyone can add new applications to our IPFS ecosystem view. There's a ton of new ones here, all from kind of the content creator side with folks who are doing video or audio or other kind of content creator first networks on top of IPFS, which adds a lot of benefits around giving people more ownership over the data and not having to trust or be bottlenecked by a middleman, to more social media use cases, identity use cases, a lot of DeFi use cases. I'll talk about that briefly, and then a lot of really cool integrations and collaborations. So lots of expansion here, even just in the past year. And we also last year saw a lot of growth in the wider network as well. And we're excited to see that many of those nodes have also upgraded to our most recent release, which, or maybe since 0.5, which is our May release. A number of folks have upgraded since then. So we have hundreds of thousands of nodes in the network, many of whom are running the most recent improvements to IPFS. And we also, in addition to running kind of this distributed network of nodes, also run an HTTP gateway whereby we make the content living within these nodes within the IPFS network, accessible over HTTP to all sorts of, classic browsers that are not yet IPFS enabled. And where we run one of many gateways, Cloudflare runs a gateway, a number of pinning services and other tools also run gateways like Pinata and Fura and others. Just on our little subset of this, we're seeing really massive amounts of people who are utilizing that tool, which demonstrates there's even more valuable applications building on top of IPFS and putting valuable content within that network and wanting to make it accessible and have a smooth upgrade path kind of into that Web3 world. And the data has also increased very precipitously, so lots of exciting data being used and shared there. So the main meat of what I wanted to talk to you guys about today were some of the awesome trends we're seeing in 2020 across this stack. Kind of starting with Q1 with the D website explosion. A lot of amazing tooling here made massive gains and eased access to putting websites and web tools on top of IPFS, and so we'll talk about that briefly. Q2 is when we made a whole ton of performance improvements to IPFS, released our biggest upgrade to the protocol in a long time, which brought a lot of performance improvements to all different parts of the IPFS data cycle. Q3 was a lot of upgrading some of the standards, both within IPFS and the way that IPFS works in connects into other ecosystems, and making some new friends, bringing some new folks to the top of the IPFS stack and the application ecosystem. And then finally, what we've seen in Q4 with a number of new protocols coming out, either building on IPFS or libp2p or both, in order to kind of become, first level chains or other things like that. Cool, so jumping into things. One of the awesome trends that we saw really take off in kind of the February, March timeframe was uploading and making it really easy for people to add DWeb sites built on top of IPFS, but easily accessible on the web. And a good amount of credit there goes to groups like ENS and Unstoppable Domains that made it really easy to upload a file and connect it to a DWeb protocol, so that you could have, momac.eth and easily resolve that in the browser and be able to serve a fully distributed page there, not running through DNS. Unstoppable Domains similarly created a whole set of templates where you could easily put up these kind of DWeb websites in a really easy way. And so this is like the hop here was less of the technical and more of the tooling side, making it easy to have that kind of end-to-end flow. And so we're seeing kind of coming to a point with the IPFS protocol and the ecosystem where it reached a new level of developers and folks who could access it without having to, say, go through command line interfaces or interface directly with kind of Hugo from scratch. You could work much more simply with the protocol in a really nice to manipulate way. And actually, one of the groups that came on the scene and drove huge adoption here and I think reached a whole ton of folks in this wider ecosystem was Fleek, who built a very smooth deployment platform where you effectively connect any content address website on GitHub, and it will publish to IPFS and just smooth every new PR to that site, gets auto deployed. It really, we have migrated many of our websites to using Fleek, and it smoothed the developer journey there in some really important ways, which I think is the next step for Web3 in general, is to unlock usability and adoption by new sets of groups by building this sort of tooling that can reach out and support a set of use cases and developer flows that just have been very difficult previously, because we've been spending so much time on the low level infrastructure and capability side of things that we've neglected that end user development flow. And so Fleek has come in and kind of helped solve that problem, which helped catalyze this amazing explosion of DWeb sites. So examples of folks who took advantage of that, Ethereumorg went and put their site on IPFS and ENS, so you can view that at ethereum.eth.link. Origin created a whole set of DWeb stores where you can go and buy swag from various different providers. So Brave has put their swag store up on Origin using IPFS, which is pretty cool. There was also this awesome explosion of DeFi sites who are using IPFS to have a fully distributed front end that doesn't rely on any single party to keep that website up, which really helps with the decentralization of sites like Uniswap, Kyber, Ether Wallet, things like that, where, again, the core app, like back end of the application lives in the blockchain, the front end is distributed on IPFS, and you have no central party that's a bottleneck or fully in control of that platform. And kind of this awesome movement of sites into the DWeb culminated with IPFS actually getting default IPFS : support in Opera for Android in I think the end of March, beginning of May timeframe. And so that was super exciting to see that browser journey and the set of sites that have been being built up in the IPFS ecosystem become more accessible on various platforms that people are using and wanting to access these sites more directly. Looking at Q2, this was our major IPFS release quarter, and so a lot of time spent this quarter was the upgrade and release of these performance improvements, and then also making sure that the tools we used in order to validate and benchmark and optimize the improvements we were making to the protocol also became accessible to the wider ecosystem. So kind of in the April timeframe, we put out IPFS 0.0, which contained a whole ton of different performance improvements to adding data, providing data to the network, finding data within the network, and then finally fetching that data from various peers. One of the big pieces of this was refactoring and cleaning up the IPFS DHT. As the network had grown 30x in 2019, we definitely hit a number of scaling challenges, and so this refactor helped clean out a number of nodes within the network that were not doing a good job serving queries, and update some of the logic within the DHT to better identify where content was and search the network better. So one of the first challenges was we had lots of connectivity gaps where people were joining the network, were undialable, and then queries would take a very long time, since you'd end up going down many false roads where you couldn't end up dialing the peers at the end of the network to get to the next step. And so by actually segmenting the network into nodes that would participate in the DHT, being servers of the DHT, versus consumers of the DHT, or just clients, that differentiated, and we automatically were able to detect whether or not you were dialable and therefore could participate as a good server of the network. That helped us default nodes into the correct configuration for them. So if you're behind like a home local area network and you're not able to serve a query, you wouldn't join the network as a server, and therefore you wouldn't end up being a gap or someone who's not able to effectively forward on queries to their correct destination. And so this helped us in many ways remove a set of nodes who were previously slowing down our queries and having dead ends. Then the next thing we did was we made sure for the good nodes you were connected to, you stayed connected to them. And so this was a lot of improvements, both to AutoNet and to the routing tables within our DHT. So understanding which peers are valuable, where you have open connections, and that you are prioritizing peers and keeping them in closer buckets when you ask them questions and they succeed at giving you what you wanted. And so that helped us avoid removing good peers that we wanted to stay connected to, and avoided a lot of churn in your routing table, which might then cause you to mostly have nodes that aren't well connected in the network. And then finally, this was like the direct query logic within the DHT. We made a lot of updates to our Kademlia implementation that helped us do the hops in the network, where each time with our DHT, looking a set closer to the nodes that are likely to have the content that you're fetching. And so we improved our query time. We tested this super heavily. This was, this is a very core part of whether the DHT is functioning or not. And so upgrading this required a lot of validation and simulation to make sure that we were actually improving the query logic. But this helped us vastly improve the speed at which we were able to find the content desired in the network. So as I was mentioning, we needed to do a lot of testing and a lot of simulation in order to make these changes. These are pretty fundamental changes to our DHT implementation, and deploying those to a network of millions of end users and hundreds of thousands of nodes and crossing our fingers that it worked was not going to cut it, not even close. And many of these things we couldn't just on a local network, simulate the sorts of changes in a live context that we needed to validate that our improvements were going to be useful. So we actually went and built our own testing framework so that we could do this. And we built it in a kind of abstracted way so it can be used by any sort of peer-to-peer network or protocol in order to do distributed simulation of node jitter and latency and configuration and even version compatibility so that we could evaluate this. And we use that to grab a lot of different data and benchmarks for what those nodes would, how this would perform in a live real network with hundreds of thousands of nodes. And so we ran our new DHT improvements through this over and over again, and it allowed us to optimize. For example, one of the really important and valuable improvements we got here was 20 to 30x faster improvement in providing data to the IPFS DHT. Still a lot of room to go here, still a lot more we can do to make this even faster. But these sorts of massive changes, when viewed within our testing framework, were helped us validate that we were on the right track. Similarly, when we're finding providers of the content we're looking for, we were able to make 2 to 6x faster improvement for fetching data from IPNS, which is our mutable naming system that's built on top of IPFS. We were able to get approximately 5x faster. And then actually for IPNS over PubSub, which was something that we added as part of 0.5 and then stabilized kind of the release after, we were able to make putting and getting with IPNS also a ton faster. Still more improvements there as well, but able to refactor a system that had some significant performance hiccups into something that works pretty reliably. So in all, we were able to look across IPFS 0.4.23, which is our release ahead of IPFS 0.5. And this one, we were able to see really, really massive performance improvements for finding data in the network. Went from somewhere from 8 to 42 seconds, which was just unbelievably slow and very, very painful, to sub-second in most cases. And now we're seeing, I think, 95th percentile as of now. As more nodes in the network upgrade to the latest versions of IPFS, this continues to get faster and faster. So I think we're seeing even better metrics than this, where 95th percentile content routing is now below 3 seconds, which means that the vast majority of queries in the network are completing very fast and are able to, again, still we would like to see these in the millisecond timeframes for many use cases like loading pages, but huge improvements here from where we were at the beginning of the year. In addition to finding content in the network, another area we collaborated with Netflix actually to improve was transferring data in the network. So, depending on your configuration, you may, as an IPFS node, be spending a lot of time actually syncing data between other nodes or fetching data from many nodes at once in order to benefit from having this kind of peer-to-peer architecture. And that was the use case and challenge that the Netflix team was working to solve from kind of a CI/CD pipeline platform. And so we made a ton of improvements to Bitswap, which is our data transfer algorithm, in order to be more efficient with fetching content from many nodes at once, so that you could quickly sync content from, say, a whole array of nodes to spin up a new build or new CI/CD node, and it helped remove a lot of the wasted bandwidth of asking multiple nodes for a block and then getting that block from everyone and then ending up with a lot of duplicates. We were able to bring that way down and also increase our parallelism and throughput, which was great. As part of that, from a content exchange perspective, we also added some very early support for Graphsync. Graphsync is the data transfer algorithm that was developed kind of in part thinking directly about blockchains and how blockchains want to exchange content with the network, where you have very deep chains of parents, and you want to make sure that as you're fetching data, you're able to kind of pull each incremental block, not with a round trip in between where you like, get the parent, then you ask for its parent and its parent and its parent. You want to make one direct query all the way through the history of the network. Graphsync has a selector language that allows you to effectively do like a send me all parents of this node sort of request, and then sync all of those back and forth. And so there's ongoing work in progress to work on bringing Graphsync and Bitswap closer together, but we added responding to Graphsync requests as part of IPFS 0.5, which kind of brought some of those capabilities to IPFS as well. For the people who have really massive amounts of data, and just in general, this is a super useful tool that can be used in a whole ton of different ways, but from a content routing or from a content exchange perspective, super useful is the ability to actually export whole graphs of data reliably and then import them. And so this is actually really useful in the Filecoin case and also in kind of an offline data transfer case where you have really massive amounts of data, where what you really want to do is export an entire graph of data and then import it on the other side instead of, say, sending it over a wire. Maybe you want to put it on a USB and mail it to someone because it'll honestly be faster. And so this was added also to kind of the performance improvements within IPFS. We also added a number of important things from an ad performance perspective and from a hardening perspective. So some of folks here may have heard about the improvements to Gossip Sub, which is the kind of peer-to-peer gossip exchange protocol that's used by many blockchains who are using libp2p as their peer-to-peer networking layer. And this also used a ton of the testing using TestGround in order to simulate a number of attack scenarios and validate and make improvements to Gossip Sub that could then prove resilient to those sorts of attacks. And so worked with a number of different groups, Ethereum, Filecoin, and others to identify the sorts of attack vectors we needed Gossip Sub to be resilient to, simulated those attacks, made those improvements, and then we're able to demonstrate using TestGround that Gossip Sub was now resilient to those, and put out a paper as well on kind of the Gossip Sub v1.1 spec, which is now what blockchains like Falcon and ETH2 are running on top of, which is really awesome. Cool. Looking at Q3, this was a quarter of standards. And so we took a number of protocols that had either been experimental or had been kind of on their way to being phased out and started making them default. So the quarter of defaults, we added quick support by default. This had been kind of experimental in IPFS for a long time and is now the default. So the quick spec had been evolving. Finally, things solidified around draft 28, and we were able to solidify that and make it the default. And it adds a number of benefits around using fewer resources and therefore and being able to maintain revive connections much more quickly, which is really great. We also added TLS by default. So we now have kind of a default standard security transport, replacing SecIO, which was kind of our, before TLS 1.3 was solidified, kind of our version of it, which in addition, we then deprecated so that we were now using TLS 1.3 and also added noise support so that we had cross implementation support, including in browsers where kind of libp2p over TLS isn't available, isn't an option. And so now we have implementations in noise across browsers, and we have TLS 1.3, which is the default when you're working between, say, like Go IPFS or Go libp2p nodes. And then we're able to deprecate SecIO, which is also very exciting and means that we also, very much encourage people to be upgrading to these latest security transports and to stay connected to the newer nodes in the network who are now using different defaults. I think TLS was added to Go IPFS nodes back in early 2018. And so if you are more than 2 years old, definitely make sure that you are upgrading on the network because newer nodes you'll no longer be able to talk to them if you do not have TLS support. Another thing we worked on standardizing in Q3 was the unified pinning service API. There's a number of different pinning services that have grown up on IPFS. There's Infura, there's Pinata, and there's a number of others. And we are working to bring these groups together and create a unified API so that any application can kind of have a seamless interface and support multiple pinning services all at once using the same API, and simplifies the development experience and makes it easy to have kind of give more of that optionality to the end user of an application. And we've been working to integrate this in the IPFS web UI so that you can, you're uploading files to your local IP, load them up to a pinning service, and kind of that redundancy and resiliency by default, which is really nice. And then finally, not within IPFS, but IPFS and IPNS were both added as registered protocol handlers in Chromium. And so in many places where you have Chromium-powered browsers, which is at many places at this point, those are now available to be added and registered there, which is a great step for web browser support. Speaking of new friends, we spent a good bit of time documenting some of the awesome groups who are building on top of IPFS so that they could share kind of both what brought them to IPFS and what their development architecture and story looks like. We have a lot of different people who are using and building on IPFS in different ways. So if you are excited about starting your own thing on IPFS and you want to learn from the motivations and the kind of upgrade path of other people building on the platform, this is super useful. And there's a lot of good information within here about groups like Fleek and Audies and OpenBazaar and how they architected themselves on top of IPFS. Benefiting from that and kind of in parallel to that as well, Falcon Ignite, which started in the July timeframe and is ongoing with a number of different programs from Gitcoin Apollo to Tachyon's Falcon Launchpad and HackFS with ETH Global, all brought a ton of new projects and teams to our IPFS ecosystem and kind of stack here using IPFS, using libp2p, and using Filecoin. And so we saw over 100 new projects building on IPFS just within Q3. I'm sure this is continuing to grow, and that was amazing for us as both like a feedback loop of many different teams building on top of the project all at once, and also kind of finding their own niches and being able to help and support each other. It's been great to see these teams come out, and many of them are kind of continuing and formalizing these things you know, with even deeper accelerators and becoming like very stable parts of the ecosystem, which is super exciting to see both that kind of top of funnel adoption and help us improve the developer journey to make it easier and easier over time. I'm almost out of time, but Q4, probably the main thing that many folks already know about was all of the work of launching the Filecoin mainnet. Was a really awesome moment for the entire interplanetary stack and all of the protocols that are used within Filecoin in order to kind of make that network successful, and also for many people in the Filecoin ecosystem who are also kind of making development kind of within the IPFS ecosystem, utilizing Filecoin for longer term persistence and storage. Many of those groups also launched improvements and tooling that makes that easy from a development perspective. If you want to hear more about the ways we contributed to or how we see this evolving, really recommend watching the talks from Filecoin Liftoff Week on the Filecoin YouTube channel. They're phenomenal. We also saw a couple of other groups launch awesome protocols on top of IPFS. Audies launched in the October timeframe with over 1 million monthly active streams. And ETH2 actually just launched yesterday, which is awesome. And they're using libp2p and actually have funded and helped create a number of different libp2p implementations. And there is now 4 client implementations interoperating on the Beacon chain. So huge thank you to these teams for like helping push libp2p forward and making it better. Super exciting. Cool. And my call to action for you in my last minute is we are actively working on IPFS 2021 planning. There's a lot of stuff happening in the ecosystem and a lot of ideas on how we can continue to make it better and where we should focus our time as, you know, both some of the core working groups and then also this entire ecosystem of awesome projects who are trying to work within the IPFS ecosystem and make it better. And so 15 proposals already, awesome conversations happening. Please jump in if you want to talk about IPFS 1.0 or content permissioning or new DHT improvements. Come join the conversation. We would love to hear your thoughts. Cool. Well, my sneak peeks will then be sneak peeks in 2021 when we actually have more to share. And thank you guys so much for your time. Feel free to message me on Twitter if you have anything going on.
Awesome. Thank you so much, Molly. The work you and your team is doing is so important to the community. Amazing to see the amount of companies contributing and participating in the IPFS ecosystem. The future is certainly bright. We're absolutely thrilled to have you here. Thank you so much.
Absolutely. Thank you guys so much for having me.
We have 2 questions in our Q&A for you. First question, what's the plans for merging IPFS and Filecoin ecosystems?
Yeah, I would say a lot of this is organic. Like, it's just honestly happening on its own accord. And it started, over a year ago. Lots of groups within the IPFS ecosystem were already looking to things like Filecoin, or were attracted as that is an upgrade path for them for keeping data storage around and accessible. A number of groups who have been building developer tooling and APIs with the system, Infura, Textile, Fleek, others have already dived deep into Filecoin and are some of on how to configure, use it from a developer. And so this is well underway. Definitely go look at some of the videos. These groups are highly overlapped, and in many ways, using Filecoin is using an IPFS node. It runs on top of the same protocols. It uses libp2p. It has IPLD data to add new data to the Filecoin network. You first turn it into IPFS shaped data and send it over libp2p to people. So in many ways, these are already very shared ecosystems. Obviously, like, not all IPFS use cases are going to utilize Filecoin, which is awesome and perfectly fine. But like, we see these as very overlapped and complementary.
Awesome. Apart from Fleek, what is your personally favorite project using IPFS?
I spent a while thinking about this last time, and I avoid picking favorites in the IPFS ecosystem because I love all of them and they're doing really, really amazing work. The one that I'll actually shout out to, which is not technically in the IPFS ecosystem, is Matrix. I guess now called Element. I love their team. They're just phenomenal. They think really thoughtfully about kind of the content moderation and agency of nodes in the network. And they've actually started building a P2P matrix or P2P element on top of libp2p, which is super cool. And I'm really excited to see where that one goes.
Awesome. Thank you so much for your time today. Greatly appreciate it.
Absolutely. Thank you so much.
Take care.
You too.